Greetings, Earthlings, and hello again to all my friends, students, teachers, pets, relatives, whatever you want to, whoever's watching the video, you know what it is. It is Mr. Benjamin here saying hello. And due to popular demands, I have, give me a second, wait for it, or I don't. Okay, you know what? I'll just put the goat again, the baby goat. But if you give me just a second, I'm gonna find some emojis. Alright, I'm back. See, I didn't even leave that long. Remember, this is our kid. He's a baby goat. And I have a couple of new additions. First of all, we're going to throw in this thumbs up. Whoa, I'm messing everything up. I'm sorry. Okay, where did you go? Nope. Not a good way to start. Select. Thumbs up over here. Done. And one more. Let's put our happy face, not on top of our goat, that's horrible. Right here. I think that looks good. Happy face with sunglasses. Boom. Boom. Alright, let's get into it. It is Chapter 7. We're moving on to 2D geometry. Students in my class, we have just finished integers, but just like with many things in life, we're still going to be talking about math. Learning goals for this lesson. We are going to locate positions on a Cartesian grid. That sounds really strange, I guess to say, but it's really just a graph, which is why we have this background today. Everyone has seen graphs before, and even if you haven't, we're going to be looking at them today. And we're going to try to make weird shapes like this upside down pentagon, or maybe even a triangle, which kind of looks like an hourglass, but you know. We're going to be doing this with integer coordinates. Definitions are integer. This is just any positive or negative number. Or negative. I can't fit that in there. I'll try it again. Any positive or negative whole number. Remember, number, not hashtag. And for our Cartesian coordinate system, this one might take me some more space, but I'm going to try writing it all out anyways. Bear with me here. So, this is a method for describing a location by identifying the distance from a, and I'm going to run out of space here, so what I'm going to do is I'm going to move my integers. You know what, I'm going to make it a lot easier on myself. I'm just going to erase the integers. Hopefully you have the definition, and if you don't, you can just rewind the video and get it down. And now I'm going to move everything else to give myself more space. Done. I don't know what happened there. Still says integers. Okay, undo. This can be erased. Bye-bye. Technical difficulties are at a maximum today. I apologize for that. I cut that away. I'm erasing this for like the 5th time already. And let's paste that. Perfect. Done. So, Cartesian coordinate system. Oh man, my definitions is gone now. Dockery is not being friendly today. A method for describing a location by identifying the distance from a horizontal number line, which is also known as the x-axis, which is kind of like that. 0, 1, 2, 3, 4, 5. And a vertical line. Which is like that. Vertical's up and down, and horizontal is left and right. capital T, axes intersect at 0, which means they go through each other at 0. 0 is also known as our origin digit. That's 0 right there. The location of each point is represented by, and I know you can't see this part down here, so I'm going to draw a line up here. Each point is represented by coordinates in a pair known as x and y. X is our horizontal, y is our vertical. So this is a really big mess. I apologize for that. I'm going to try to explain it on the next page. When we think about our grid, our Cartesian plane, Cartesian coordinate plane. Okay, this is what this is. All this right here, Cartesian coordinate plane. We can think of this as two really, really big number lines that intersect at 0.
Good afternoon, our ladies.
So sorry, I had to pause the video there because the announcements came on. Yes, I'm still at school. I'm still recording this. Anyways, when we think about coordinates on a grid, like I was saying, we're going to say that these are two really big number lines. Now, each number line is going to have 0 in the middle, and let's make this a 1. We're going to say each space is half a unit. So these sides, these are all positive numbers, right? Over here, we're going to have negative numbers. And it's going to be the same when we go up and down. So that's going to be positive 1, positive 2, positive 3. Over here, we'll have negative 1, negative 2, and negative 3. So this side over here, our x and y's, our coordinates are going to be positive and positive. Over here, our x and y will be positive and negative. Here our x and y will be negative and negative. Here our x and y will be negative and positive. The reason for that is we always read x, the horizontal component, first. So if I had a point like, let's say we were looking at a point of negative 3 and 2. Well, I'd read negative 3 first. Negative 3 is over here. I would find that, and then 2 is positive, so I would go up. Negative 3 and 2. It's going to make more sense on the next slide where I'm going to do more examples. So, plot the following points. Let's draw our grid. Our first point is 4 and negative 2. Now I'm going to say that each unit, each square is 1 unit. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, etc., etc., etc. And here it's positive 1, positive 2, positive 3, negative 1, negative 2, negative 3, negative 4. So our first point is 4 and negative 2. Remember, this is x and this is y. X being horizontal, y being vertical. So looking at what we have, x and y, we have x of positive 4. So we're going to find positive 4. Starting at 0, go across positive 4. And now our y component is negative 2. Now negative 2 is down. Remember, this side is negative, this side is positive, this side is negative, this side is positive. So we're going to go down 2 spots. So there's our first point, A, which is 4 and negative 2. Now let's try B. B starts off at negative 3. So 1, 2, 3. Negative 3, and then it goes up 3. 1, 2, 3. There's B. Negative 3 and 3. And C is 5 and 5. So we got to go all the way over here to 5, and all the way up to 5. So we're going to give you a bit of a challenge, or a try this, as we like to say. We're going to plot the following points, then connect them naming the polygon that we are making, or the shape in this case. So the first one, let's do point D as -3 and 1. Remember, that's x and this is y. E will be -3 and -3. F will be -1 and -4. And G will be, I'm going to get rid of that, x and y. G, we're going to say, is -1 and 3. So make sure I got these all correct. Yep, that should be good. And the second shape I want you to make, A will be 0 and 5. B will be 4 and 5. And C will be 4 and 0. Alrighty. So you can pause the video there, write those down, and try to draw them on your own Cartesian coordinate plane system. As always, at the end, we are going to say thank you. And let's get our thumbs and our... Where's our thumbs? Thumb can go there. And how about our smiley face? Smiley face can go here. And because I think he is awesome, we're going to get our kid in here as well. Let's put him sideways. There you go. Thank you. Have a wonderful day.